Welcome to the Introduction to Well Control program, Module 5, Causes of Kicks. Before beginning this module, you should be able to describe how the density of a fluid and well depth affect pressure, define hydrostatic pressure and calculate it, and describe how the drill string and annulus can be represented as a U-tube. In this module, you will learn to identify the different conditions that can cause a kick, describe how a kick develops, describe the warning signs and indicators of kicks, and describe the effects of a gas kick. We saw in Module 3 that drilling without enough hydrostatic pressure to balance formation pressure is called underbalanced drilling. Except in special circumstances, underbalanced drilling is never done deliberately. It generally happens for two reasons. One is drilling into an abnormally pressured zone. Another is dilution or deterioration of drilling mud. You'll recall that in normally pressured formations, the pressure gradient is consistent. As you go deeper, total pressure increases at a uniform rate. As we saw in previous modules, the value of the normal pressure gradient varies slightly and depends on what part of the world you are drilling in. In many locations around the world, normally pressured formations have a pressure gradient of about 0.45 psi per foot, which is approximately equal to the pressure gradient of seawater. We'll use this as the normal gradient for the next exercise. When drilling normally pressured formations, the engineer selects a mud weight or density sufficient to counterbalance the normally pressured formation. In this example, let's say the engineer chose a mud that has a 0.46 psi per foot pressure gradient. What weight mud is that? You will recall